But here's the issue. While my device may stop participating, my prior updates remain in the global model. The system still benefits from my data even though I have opted out. This violates the data ownership principle because without a mechanism to undo my contribution, we are essentially saying that once you have contributed, we own your influence forever. And that's ethically and legally unacceptable. Federated unlearning is about respecting that boundary, ensuring that when someone opts out, their data stop being used. Finally, the scalability, that is computational and storage constraint. But here's the issue. So even if you wanted to retrain the model every time data deletion request comes in, you can't, because retraining from scratch is resource intensive. And for large scale federated systems with thousands or millions of devices, it's simply not feasible. So what needed is a solution that enables target data removal without resetting the entire learning process. So this is what federated unlearning is. Now that we have seen that why federated learning falls short when it comes to privacy, compliance, and robustness, now I'll talk about the potential solution. So at first glance, it might seem that the solution is simple, just delete the data. But in artificial intelligence, deletion is not equivalent to forgetting, which is further not equivalent to unlearning. These are the three concepts which are interrelated but addresses very different aspects of data removal and model behavior. So first one is deleting. So this is the most basic form of data removal, that is physically erasing the raw data from the storage system. In most IT system, deletion is considered sufficient for compliance. That is, the file is gone, the record is purged. But in machine learning, that is not enough, because even if we delete the user raw data, its influence may still persist in the model weights. For example, if a driver data was used to fine tune a traffic prediction model, deleting the CSV file does not erase the learned pattern. So while deletion satisfies the storage level compliance, it fails the model level privacy. Next is forgetting. In artificial intelligence, forgetting usually refers to what happens when a model is exposed to new data, and over time it loses its ability to recall the older patterns. For example, if you are training your model on a dog cat data set, and then after that you are going to retrain it on birds, eventually the model forgets that how to identify the cats. But this kind of forgetting is unintentional and uncontrolled. It is also not traceable and verifiable. You can't precisely say that when and how specific user data was forgotten. Also, it can result in catastrophic forgetting, where useful information is lost along with the targeted data. Uh, in critical applications such as healthcare, this kind of forgetting is dangerous and unreliable. So that brings us to unlearning, the most powerful concept. So unlearning means intentionally removing the influence of specific data from the trained AI model, such that it is as the data was never seen in the first place. And this is what exactly GDPR is asking for. But unlearning comes with various key challenges. For example, how do you pinpoint the influence of a single user's data? The second one is, how do you efficiently remove it without retraining from scratch? And also, how do you verify that the unlearning is successful, especially in case of your black box model, where you don't know the working of those model, how they are going to generate the outputs. So now we will discuss about federated unlearning. But before that, I would like to discuss about traditional unlearning. So in case of traditional unlearning, the centralized server are responsible for unlearning. So basically, single entity has a full control over the model and the training data. However, in case of your federated unlearning, there are multiple stakeholders which are involved in the process. So for example, your unlearned client. So unlearned client is the entity who is requesting for unlearning, or the one who has opted out from the learning process. The other one is the remaining client. So remaining clients are the other nodes which are present in the network. So the influence of this unlearning should be removed from these clients. However, these clients will participate in the learning process in the future. And the last one is the central server, which orchestrates the model updates and ensure that the model parameters are adjusted correctly to eliminate the unwanted influence. Basically, federated unlearning needs to ensure that the model adapts in such a way that targeted data contribution is completely and verifiably removed from all the nodes, that is from the central server and from the other clients which are participating in the network. So basically, in case of federated unlearning, there are three phases involved. The first phase is the federated learning phase. So this is where the model is initially trained using the data from multiple decentralized clients. Each client trains locally and send model updates to the central server. The server aggregates the weights, and these updates are used in order to form the global model. Then comes the unlearning phase. So if the client requests the data removal, we enter into the unlearning phase. The goal here is to remove the influence of that particular client from the model. This step should be performed very carefully so that the model should behave like the data from that particular client has never been included in the global model. And then after unlearning is complete, the model undergoes the verification phase. This phase check if the data was successfully removed or not, both functionally and from the privacy point of view. Verification ensures that the model is compliant with various privacy regulations. Now, unlearning can be handled in two different ways depending upon the client's involvement. So first one is passive unlearning and the other one is active unlearning. In case of passive unlearning, it occurs when the client has already left the network and it is the only server who is going to handle the unlearning process independently. So basically in this, no further input from the unlearned client is received. However, in case of active unlearning, it happens when the unlearned client is still active and can participate in the unlearning. So in case of active unlearning, both server and client perform the unlearning process together, and this method is more accurate as compared to passive unlearning, because here in this case, the unlearned client is going to guide that how to remove its effect from the global model. Now that we have understood the phases and the basic type of federated unlearning, now we will going to discuss about different federated unlearning scheme, focusing on who performs unlearning, what is being unlearned, and how to achieve that. So first question is, who performs the unlearning? So this we have already discussed, that either the server independently perform the unlearning, that is called passive unlearning, or the server and the unlearned client jointly perform the unlearning process, that is active unlearning. After that, the question is, what is being unlearned? So there can be three type of unlearning based on this question. First one is unlearning the entire client. So in this case, all the data and the contribution from the single client users are removed from the model. The other one is unlearning the entire class. So it is something like removing specific class or categories. For example, your unlearning request in this case can be unlearn all the images of cats. So this will unlearn all the images of cats, and the model is not going to identify the images of the cat in the future. And the last one is unlearning partial data. So here only selective samples from the client database are removed and not their entire distribution. So this kind of classification gives flexible level of unlearning based on user intent and privacy demand. Now the next question is how unlearning is performed. So there are several strategies which are used in order to perform unlearning. Basically, these are categorized into mainly two parts. So the first one is making the changes in the model. So the category, so the schemes which falls under this categories are retraining, fine tuning, gradient ascent, multitask unlearning, and model scrubbing. And the next one is using synthetic data. So we are going to discuss about these in detail in the future slides. And after this, the next phase is verification of unlearning. So once the unlearning is performed, we are going to verify that the unlearning was successful and privacy compliant. So it can also be of two types. You can either verify at the server side, or you can verify the learning at the client side. In order to do the verification at the server side, various methods, metrics based methods, for example model accuracy drop or influence measures, can be used. And if you are going to do the verification at the client side, various attack based techniques can be used. For example, you can simulate a membership attack in order to check whether the data has been removed from the model or not. So yeah, so here we will discuss that how model unlearning can actually be implemented in practice, specifically by modifying the trained model itself. So this approach basically involves directly altering the model to remove the influence of specific data points or classes, usually for reasons like privacy. So basically the three main categories in this are, first one is parameter pruning. So this technique basically selectively remove or modify the model parameters that are strongly associated with the data that we want to forget. It is the quick way to reduce the model memory of sensitive data without having to retrain the entire model from the scratch. So it's like trimming the part of the model which is going to remember that unwanted data. The next one is fine tuning. In this method, we retrain the model slightly using the fresh iteration, so that the influence of the previous data has been removed from the model. So it's like refining the model to rewrite the influence of unwanted data while still maintaining the overall performance. And the third one is a gradient reversal. So it is more targeted approach by applying a reverse gradient to specific data point. So this helps to cancel out their influence from the model. So it's particularly useful when we want to unlearn the data at fine grained level, but still to preserve the integrity of the model. And so various techniques like gradient direction rectification or gradient magnitude adjustments can be used. Now, the other type is unlearning using synthetic data. So this approach involves using artificially generated data to replace the real data that was deleted. So which enable us to fine tune and retrain the model without compromising the privacy and performance of the model. Now, the key advantages of using synthetic data in unlearning are: first one is anonymization. So since synthetic data does not directly refer to the real individuals, so that's why model can learn journal patterns without retaining any kind of personal information. The other one is stabilization. So when we are going to remove a particular sample or class, uh, it uh, it can result in disturbing the performance of the model. So in that case, synthetic data can help to fill those gaps while preserving the overall distribution and structure of the original data set. Yeah. So now, since federated unlearning become difficult in dynamic systems, because in case of dynamic system, the clients are not static. They can frequently join the network, they can leave the network, or they can get disconnected from the network. So the techniques which we have discussed are not suitable for this kind of system, which is dynamic in nature. Now, what are the challenges that we face in dynamic system? So first one is storage overhead. So most of the unlearning algorithms that we have discussed require the server either to store the previous updates or the gradients or the client contribution. So in case of large scale federated network, this is not possible because there is a storage constraint. They need to store a huge amount of a gradient information in order to perform the unlearning process, which is not feasible. The second problem is client churn. So basically, clients often participate in case of for dynamic system intermittently. So many existing unlearning method depends on client being available to reverse its own data. But what happens when the client is offline or already left the network? And also some techniques rely on model reinitialization to forget the data, which essentially throws away all progress made up to that particular point. So this is inefficient and impractical, especially in continuously learning environment. Now, for federated unlearning to work effectively in a real world where we have various dynamic systems or ever-changing environment, it must satisfy three major demands. That is, first one is on-the-fly learning. So basically, modern artificial intelligence application must adapt in real time, whether it's adapting to new traffic condition, financial market, or user preferences. Federated unlearning must enable learning and forgetting simultaneously. The other one is non-IID data support. So basically, the data in federated system is often non-independent and identically distributed. This means that the client might have the data from different distribution, and unlearning must work even when the data is unevenly distributed, sparse, and imbalanced. Because unlearning can make, uh, for example, if you are going to unlearn some data, it can result the model to become biased in the future. Because if you are going to unlearn the data of, for example, your model is learned on a data set consisting of all kind of people, like white people, black people, right? And the request is to unlearn the data related to white people. Now in the future, since we don't have any data related to white people, so the your model has become biased. So your unlearning should be something so it can support non-IID data also. The other one is multimodal data diffusion. So many real world systems work with diverse kind of data, for example, your images, audio, sensor data, and text. So federated unlearning techniques must support unlearning across these modalities, which is significantly more complex than handling single data type. So addressing these demands is what allows federated unlearning to move from the theory to practical deployment. Yeah. Now we will discuss about Fedamnesia, which is a federated unlearning framework that we propose in order to address these key challenges which we have discussed. So this Fedamnesia is built on three core concepts that work in together in order to ensure privacy preserving and efficient unlearning. So the first one is incremental influence nullification. So this is responsible or this technique limits the influence of client contribution before they are integrated into the global model. By modifying the local training process, this incremental influence nullification ensures that any data marked for potential unlearning can be removed with minimal impact to the overall system. It minimizes the footprint of that particular data by making its influence more traceable and controllable. The other approach is memory efficient influence decay. So it gradually attenuates the impact of unwanted data in the model over time. It avoids the need of full retraining by adjusting the parameters in order to diminish specific influence while preserving the knowledge gained from the legitimate data. So basically, this memory efficient influence decay is responsible for preventing catastrophic forgetting, where unlearning is too aggressive and can also result in erasing the valuable learned behaviors. The last one is on the fly adaptive nullification. So it addresses the fairness and balance in learning. So when the data is removed, it redistribute the learning contribution across different clients or the data sources. So basically, this is used in order to avoid any kind of imbalances that can be caused due to unlearning. So it improved the biased performance and instability. So it is useful in case of your non-IID settings, ensuring that the unlearning of one data point does not lead in biased scenario. So this technique combinedly allow, so all these three techniques work together and make Fedemnesia to perform targeted real-time unlearning in federated system without excessive computational and performance loss. Now the use case of Fedemnesia in case of Internet of Vehicles. So as a vehicular network become more connected and intelligent, they continuously share data across network to support traffic prediction, accident prevention, and route optimization. This is made possible through real-time data exchange between vehicle and infrastructure. However, this level of data sharing also introduces privacy concern. For example, if a vehicular owner might request that their driving behavior data be removed from the system due to personal or legal reasons. Uh, so basically, traditionally fulfilling such request would retrain the entire model or use the approaches which we have discussed already, but these are either time consuming or computational expensive. So here where fed amnesia can be a solution for such kind of situations. So for example, in this figure we see a case where entire device or vehicle want its contribution to be forgotten. So the unlearning request is sent from the vehicle to the central server. The server then perform the unlearning process and remove all the data associated with that particular device. And then the updated model now free that particular vehicular data and then redistribute the entire model again across the network. So this approach is useful in this case where user opt out entirely. The other scenario is this one. Here the user does not want to remove everything, only specific points or behavior. The user want to remove only specific points or behavior. So the unlearning request still travels to the central server. Uh, sorry, but the process only affects the subset of data. So here since in case of fed amnesia that incremental influence nullification is done, so that will check whether the particular data has its impact over the global model or not. If it has, then MID will work. Otherwise the unlearning will take place at the locally at the edge devices only. So in both the scenario, fed amnesia make it possible to handle privacy driven unlearning without full retraining. So this ensures that artificial intelligence in transportation remain both efficient and ethically aligned with the user right. Now other possible use cases of fed amnesia. So first one is healthcare. So in healthcare sector, one of the most impactful use case can be patient data forgetting. So with the rising concern of over data privacy and strict regulations, Fed Amnesia can help to ensure that personal health records are securely removed from the AI models. In addition to this, adaptive AI diagnosis can be benefited from Fed Amnesia. The other possible use case is in smart cities and edge intelligence AI. So Fedemnesia plays a vital role in dynamic surveillance data handling. So as the facial recognition and other biometric data come under increasing regulatory scrutiny, the ability to remove and modify such data from edge-based system allows the city to maintain compliance without costly retraining. The other one is in case of your energy grid optimization. So AI models can be used to manage smart grids and can adapt more efficiently by unlearning the outdated energy consumption parameter. enabling which enables more responsive and sustainable operations. And the last one is the financial sector. So Fed amnesia is a valuable tool for maintaining trustworthiness in order to remove incorrect transactions, unlearning fraudulent and misclassified data entries that could lead to a skew model over time. It can also be used in case of adaptive risk analysis, and also it can ensure that risk assessment remain relevant and robust in fast changing economic environment. Yeah. Now the challenges of Fed amnesia. So the first major challenge is scalability. So particularly in case of large scale Internet of Vehicle. So in this environment, a million of devices contributes to the learning process, each with their unique data pattern. Efficient unlearning across such vast and diverse network become computationally intensive. The key use here lies in the memory and computational overhead that increases with each unlearning request. So, the proposed solution for this challenge can be to use efficient gradient pruning along with decentralized unlearning. The other critical challenge is enabling real time unlearning without degrading the model performance. So, since in Fed amnesia, memory efficient influence decay is used, and it is performing good, but what happened, but it is not particularly useful in adaptive scenario. So the one possible solution can be to use a reinforcement learning based adaptive unlearning, which can dynamically tune the process to optimize both performance and responsiveness. The last one is the security against adversarial attack and poisoned unlearning. So as the unlearning become more widespread, so the risk of being misused is also there. Attackers might try to exploit unlearning requests in order to alter the model behavior. The key issue here is the threat of false deletion request, which can be used to intentionally forget critical information, which can degrade the model's performance. So in order to counter this challenge, various solutions can be used, or various solutions can be integrated with Fed amnesia. For example, blockchain based authentication can be done, or anomaly detection systems can be integrated with this. Now the future of amnesia. So the first one is increased, so building trust and explainability in AI. So by allowing the user to see that their data has been effectively and securely removed, Fed amnesia can build trust in AI system. So this is essential for societal acceptance as well. Ethical the other one is ethical AI in healthcare and finance. So, in these sensitive domains where decisions can significantly impact the individual, Fed amnesia enable ethical data handling and ability to correct or delete the flawed data. And the other one is real-time adaptive learning. So, as AI systems grow to incorporate more edge-based and real-time learning, Fed amnesia can ensure that unlearning is just as fast and responsive. Yeah. So next one is making AI more adaptive and secure. So basically, um, in case of Fed amnesia, whenever a request is made, then only intentional unlearning is performed. But what if your data become uh, obsolete? So that data is not giving the current trends in the markets. So Fed amnesia should also detect these kind of behavior and selectively delete that kind of data from the model. And the last one is reducing biases and fairness monitoring. So, Fed amnesia allows the selective removal of biased or discriminatory data by giving the developer a tool which can proactively improve the fairness over the time. Yeah, basically, throughout the PPT, we have seen that Fed amnesia represent a significant step toward building AI systems that are not only intelligent but also responsible, privacy preserving, and adaptable. So, from connected vehicle to smart grids, the ability to selectively unlearn the data without full retraining is essential, not just for compliance with the regulation but also for user trust and ethical accountability and operational efficiency. So while we have various challenges such as ensuring scalability, avoiding model degradation, and defending against adversarial attack, various approaches like incremental influence nullification, memory efficient influence decay, and on-the-fly federated adaptive nullification are are paving the way for real-time, secure, scalable unlearning. Yeah. So thank you, and now I am open for questions.
Thank you very much, madam, for your wonderful talk. So I can see in chat box there is one query from Mr. Shayak Rudro. Where is the difference in normal machine learning and federated learning? Why it's easy to change and unlearning in federated learning?
Yeah, so first I would like to discuss about that how normal machine learning is different from federated learning. So in case of normal machine learning, um, basically you have to send your data to the central server where the model is running. However, in case of federated learning, the model, you don't have to send your data to the global model. However, you are going to train your local models over the edge devices, and further only the weights are sent to the global model. Then the aggregation take place at the global server, and further that global model is distributed among the devices. Now the next question is why it's easy to change and unlearning. Can you please clear what exactly mean by this? Why it is easy to change and
Mr.
unlearning?
Shayagrudha, can you unmute yourself and ask the question?
I want to ask that why it is easier to delete or change some information in that federative learning than normal machine learning.
um, it's easier to unlearn in case of traditional machine learning than federated learning, because in case of traditional machine learning only there is a central server who have the access to your whole data, and that particular server is responsible for deciding that how that unlearning will take place, how it is going to remove its influence. Okay. However, in case of federated learning, see, you are not sharing your data with the global central server. You are only giving your weights. After that also, the model influence is distributed among various clients which are present in the network. So if the unlearning request is made in case of federated learning environment, then you have to remove the influence of that particular data not only from the global model but also from the clients which are present in the network. So it's difficult. So that's why it's difficult to perform unlearning in case of federated environment as compared to the normal environment. Yeah,
Okay,
next
ma'am.
question.
Thank you.
So, madam,
Next
I
is
have one question for you actually. So I am quite curious to know your opinion, and that's why I have jotted down the question in the chat box. So you can see that how can organization effectively balance the need for transparency in AI systems with the importance of maintaining user privacy, especially in the light of increasing privacy regulations. So if you kindly share your precious opinion.
Yeah, so basic, first of all, the points that how to define the privacy from every user's perspective is different. So maybe the privacy for me is different from the privacy from your perspective, right? And also, transparency is something that, for example, if a model is giving some output, we don't know how that output is generated, right? So in order to do that, it's up to the user's need. So whether a particular user want more transparency in their model, or it's up to the privacy they are looking for. For example, let's consider the case of healthcare. So in case of healthcare, um, for example, we have the data of cancer patients. So in that case, our model is used in order to predict if a user have a cancer or not. So in that case, the need of the privacy is just to not share the individual's data, but we also need that how that model is predicting whether a particular person has the cancer or not. So in that case, the use of synthetic data can be beneficial, because if you are using synthetic data, you don't need to share the you don't need to share the individual's information. And on the other hand, with the help of that synthetic data which shows the behavior of the real data, you can also predict that, yeah, whether a particular person has cancer or not. So yeah, synthetic data can be one of the possible solution for such kind of scenarios.
Okay, thank you very much, madam, for sharing your precious opinion. So, is there anyone want to ask any question to Ria, madam, from the audience? So, I think,
Ma'am, can I
good.
ask where can I learn more about federative learning to use in some projects?
For federated, if you want to learn about federated learning, then there are lots of research papers which are available. So you can go to IEEE Explore and search for federated learning. There are lots of paper, but for federated unlearning, the literature is very less. So you have to get your hands dirty, and then only you can learn.
Okay, ma'am, thank you.
Okay, so if there is no more questions, so we can felicitate madam. So, let me share the screen. So, I think the screen is visible to all of you. So, this is a small token of appreciation from our side to Ria, madam.
Thank you.
Thank you again, madam, for accepting the invitation and sharing your precious time with us. We are all grateful to you, and hopefully, in near future, if required, we can get some support from you, similar type of support from you, and we can hear some type of similar type of the interesting talk from you. So I believe that the current audience got the essence of the federated learning and how we can make deep dive from learning to unlearning in terms of the privacy-driven AI assurance. So later, it's time for the group photo. So let us move for the group photo. So I request all the participants to turn on your camera kindly. Definitely, if it is possible, then only, because it's time for the group photo. So I shall wait for a few more seconds, and then we shall proceed for the group photo. Group photo. So if possible, kindly turn on your cameras. So let us take the group photo now. Rajdeep, if possible, you also take a couple of shots from your end.
Done, Shubhadeep.
Thank you very much. Thanks again, madam, for joining the session.
Thank you. Thank you.
Thanks to the audiences as well, and please do not forget to mark your attendance in the link given at the chat box.